Our next presentation is about the growing importance of aquaculture. And the presenter is David Currie. David has been with the Food and Agricultural Organization of United Nations in Abu Dhabi since August 2012 in the post of Fisheries and Aquaculture Officer for the GCC countries in Yemen. His career since 1975 has been in the fields of fisheries, aquaculture, and coastal environment, including both in the private and for the development agencies, and with work mainly in the tropical zones of Latin America, Southeast Asia, and now the Middle East. David, it's a pleasure to have you.
Good afternoon. Maybe you've heard of the blue economy. It originates with a book by Gunther Pauli published in 2010 that proposes a shift in the way we run our industries and agriculture to a blue economy business model. His idea is that this can help solve our future resource problems and environmental issues. The full title is The Blue Economy, 10 Years, 100 Innovations, 100 Million Jobs, which gives you the idea of its aims. Pauli proposes that taking a new scientific approach based on natural processes can solve seemingly conflicting challenges with the environment, society, and economic development. He argues for moving away from our high energy usage and high use of rare resources to simpler, cleaner technologies as the way forward. His ideas have been widely supported by development agencies and governments, and FAO is working under its umbrella with a Blue Growth Initiative to bring its principles to bear on their work in fisheries. And I think it's a good frame in which to make this presentation about the growing importance of aquaculture in food security. The fisheries aspects are an important aspect of this blue economy, blue growth initiative. The oceans in particular provide us with all kinds of services and benefits that offer opportunities to be linked together in more sustainable ways. Climate regulation, transport, food. You're probably familiar with this by now. 9 million people projected by 2050. And the striking thing is this population growth has been very recent and steep. In the 1700s, there were only 1 billion people on the planet. Even 65 years ago, only 2 billion. The increase over the past 65 years is quite extraordinary. In 1980, 28% of the world's population was undernourished. But a great success story is that by 2011, this had fallen to 12.5%. Since then, increasing demand for biofuel and the world economic crisis has slowed this progress. And moreover, these figures represent only one aspect of malnutrition. An estimated 26% of the world's children are stunted due to undernourishment. 2 billion people suffer from one or more micronutrient deficiencies, and 1.4 billion people are overweight, of whom 500 million are obese. So how much food do we need? About 1,700 to 900 kilocalories a day and 58 grams of protein. Most of both energy and protein comes from plants, but about 1/3 of protein comes from livestock and about 6% from fish. Projections are that by 2050, we will be consuming 2/3 as much animal protein as today. So where is this going to come from? Given the current pressure on natural resources, livestock specialists see it as unlikely this could be met by keeping twice as many poultry, twice as many cattle, twice as many sheep and goats as today. Instead, we will need to find improvements in the efficiency of production systems, in converting natural resources into food, and also in reducing waste. And I'm going to argue that fish can play an important role in supplying this additional protein, and aquaculture in particular. Since 1967, the global production of poultry meat has increased 7-fold, eggs 3.5-fold, sheep and goat has doubled, pigs tripled, and milk and beef also almost doubled. And there's another 7 billion eggs per year contributing to that world protein. Here's the same graph without dairy to make it a bit clearer. This expansion of production over the last 40 years was largely due to an increase in the overall number of animals being raised. In 1950, when beef and pork dominated world meat consumption, poultry production was quite low, roughly the same as mutton. From mid-century onward, however, poultry production gathered momentum, overtaking beef in 1996. Advances in the efficiency of poultry production had dropped the price to the point where more and more people could afford it. You can see in this graph that fish and poultry consumption are now well above that of beef and sheep, and projected to almost double by 2050. Overall livestock meat consumption is projected to rise 73% by 2050, and dairy consumption by 58%. Meanwhile, what's been happening with production? Well, of course, it's been matching the growth as consumption depends on production. Here's the graph with dairy, and here's one without. You can see poultry, pigs, and fish in particular have been showing massive growth, and a lot of this is to do with China. Chickens are now 80% of all world livestock, with 20 billion reared per year around the world. This graph makes cattle, sheep, and pigs look quite small, but they too are around 1 billion mark each. But there's a gap here between projected consumption and what might be possible in expanding production. Let's look a little more closely at this gap. The extra demand for livestock protein comes from two things: increasing population, but also increasing meat consumption in developing countries, and again, especially in China. In the 15 years from 1990 to 2005, China's GDP grew 1,000%, and the percentage of people living in extreme poverty fell from 60% to 16%. This led to a doubling of per capita meat consumption from 26 to 54 kilos a year, and of milk from 7 kilos to 26 kilos. This trend is not stopping. We can safely assume two things are going to happen over the next 45 years. The demand for protein, including livestock products, will continue to grow, and it's going to get harder and harder to meet that demand. For instance, poultry production is going to have to double by 2050. Beef is going to have to increase 50%, and dairy the same. Is this achievable? Maybe yes, but there will have to be technological improvements, and there's going to be increasing stress on the land and water resources needed to support that growth. Or going back to the green growth, blue growth model, we have to find more balanced, sustainable ways to keep increasing protein production. What about fish consumption? Well, in the past 20 years, world per capita fish consumption has been fairly steady, while livestock product consumption has grown a lot. But if relative prices shift, this could change, and the increasing demand on livestock products is likely to make them more expensive and less available to the poor. This could increase the demand for fish in new ways. And setting aside that increasing demand for meat from more affluent societies, even if a lot of the protein needed to meet future population growth comes from plants, that will have to increase 50% also, and that too will put increasing stress on land and water and fertilizer resources. And water is another big issue, particularly in this region of the world. 70% of water usage is in agriculture and 80% in total in food production. And the proportion of people living in water-stressed regions is estimated as likely to double in the next 20 years. And here are some sobering numbers. It takes 15,000 litres of water to produce 1 kilo of beef, 9,000 litres for mutton, 4,000 litres for chicken. And big increases in livestock production will mean big increases in water demand. And it's not just water that livestock production creates a big demand for. 77 million tons of plant protein are consumed annually to produce 58 million tons of livestock protein. And growing that plant protein also needs land and water. It takes 7 kilos of grain to produce 1 kilo of weight gain in cattle, 3.5 for pigs, and just over 2 for poultry. It's interesting to compare that with farmed fish, where the demand is much lower. Freshwater fish like catfish, for instance, only need 1 to 2 kilos of grain for each kilo of weight gain. And much of the world's current fish production uses much less than that. Freshwater fish at low density can grow well with no land plant inputs, just fertilization of water. And the systems that compete least for human food, those that primarily depend on grazing, produce only about 12% of the world's milk and about 9% of its meat. It is mixed systems in which animals eat grass and crop residues as well as concentrates that produce 88% of the world's milk and 6% of its meat. 45% of the world's meat, mostly poultry and pigs, comes from intensive systems, often indoors that use little land but need a lot of agriculture supporting them with feed. 61% of the world's eggs are produced in similar systems. Fish convert feed into protein much more efficiently than land animals, and of course the sea can produce fish without using fresh water or land resources. The problem is that the catch of fish from the wild has stagnated over the last 20 years, and the prospects of expansion are quite limited. Here's a graph of world fish capture since 1970. You can see that up to the 1990s there was a steady increase of about 50%, but since then landings have stabilized at around 90 million tons. About 80 million of that is from the sea and 10 from inland waters. And about 20 of that 90 is not being used directly for human food. Since 1974, the proportion of overexploited fisheries stocks has increased from 10% to 30%. And more importantly, most of the stocks of the 10 key fish species used for human food are fully harvested, and there is little prospect of future increases. Well, with one exception, and that is what could be done by better fisheries management. FAO and the World Bank, in a 2009 study called The Sunken Billions, calculated that world fisheries could be generating $50 billion US dollars more every year if they were managed better. And that would mean more fish on the market also. But one, it will be difficult, and two, the gains would not come near solving the future demand problem. So can fish production double to meet the projected demand? Not from the wild, but aquaculture may be the answer. You can see here a graph of overall fisheries production since 1970, with capture fisheries and aquaculture together. Just about all the growth since 1990 has come from aquaculture, and this is a continuing trend. Here's a curve just for the growth in aquaculture. It has increased 12-fold in the last 30 years, and in 2011 reached 63 million tons, with an estimated value of 130 billion US dollars. Aquaculture's contribution to total food fish supply grew from 9% in 1980 to 48% in 2011. The estimated number of fish farmers also grew from 3.9 million in 1990 to 16.6 million in 2010. This rapid and massive growth of aquaculture production has contributed significantly to increased production of species whose supply would be otherwise constrained given the lack of growth in capture fisheries production. Here's a graph of how things look in 2011, with 40% coming from aquaculture. And the projection by 2050 is that aquaculture will be accounting for 53% of total fisheries supply, mainly because of the growth in aquaculture and the stagnation or the leveling off of the capture fisheries. Fish is usually low in saturated fats, carbohydrates, and cholesterol, and provides not only high-value protein, but also a wide range of essential micronutrients, including various vitamins, minerals, and polyunsaturated omega-3 fatty acids. Thus, even in small quantities, fish can be effective in addressing food and nutritional security among poor and vulnerable populations around the globe. Stunting of children's growth due to inadequate nutrition has a serious effect on physical and intellectual development. There's been a lot of progress, with the prevalence of stunting in children worldwide falling from 44.6% in 1990 to 28% in 2011. But it remains a big problem, including in this region in Yemen, where around 50% of children are malnourished. The effect on a country's economic development in the next generation is severe, and fish could help alleviate this because of the very valuable nutritional elements it contains. Most countries have sufficient land and water, but in Africa and the Middle East there are many with neither sufficient land nor renewable water resources, or in some cases sufficient agricultural land but insufficient water. Aquaculture generally has more potential in these countries than agriculture and livestock rearing. I want to just turn to the world picture of aquaculture to give you an idea what the main species are. Carp dominates aquaculture, about 40% of world production, followed by plants and mollusks. Here it is as a pie chart. So you can see with carp and plants and mollusks together, that's 96% of world aquaculture, and the others are much lower. And where is it all produced? Well, by far the majority in China. 62% of world aquaculture production is now in China. You can see that India, Vietnam, Indonesia, making up in total 3/4. And by continent, Asia is dominant in aquaculture production around the world. There it is as a map. Just looking here at the value. World aquaculture production has increased in value since 1984 from 10 to 140 billion US dollars in 2011. Fish is a highly traded commodity, with 38% of world supply being exported in 2010. This indicates that there are inherent imbalances in regional supply and regional demand for fish. A lot of this export is from less developed countries to more developed ones. It creates substantial revenues, but it can also affect food supplies. Freshwater fish still dominate the value picture, but salmon and shrimp are more important by value than they are by tonnage, about double their percentage, in fact. Often people in the West think of salmon and shrimp being the key aquaculture species, but despite this, in reality, they're quite a small part of the world picture. Freshwater fish low down the food chain are what most of world agriculture is about, and in China in particular. Let's have a quick look at China. Fish is almost half of the production, mollusks and plants most of the rest. Carp are very important. More than a third is carp. These are the top 10 world species in 2011. The silver carp, I'll show you some pictures of these species in a minute, then 2 seaweeds, then the grass carp, oysters, another carp, another shellfish, more plants, and then shrimp and tilapia in the top 10. This is the growth in Asian carp production between 1950 and 2011. And if you plot almost any aquaculture species which includes Chinese data, you will get a graph that looks like this. A horizontal line up to about 1970, 1980, and then just meteoric growth. This was the #1 species in 2011, silver carp. In fact, in 2010, it was in 3rd place behind the Japanese kelp and grass carp. World silver carp production is dominated by China with 69%, and India is another big supplier. This is the grass carp, which was in 4th position in 2011. Again, China, 97% of this fish is coming from China. This is the kind of pond that a lot of Chinese carp is grown in. Undeveloped, extensive ponds with fairly low inputs, and these are fish that feed quite low down in the food chain. And so from that point of view are a sustainable aspect of aquaculture. Carp are produced in hatcheries like these. The parent fish are kept in these circular tanks to produce eggs, and then they're typically grown in systems like this where they can hatch before stocking into ponds. Tilapia, which came in at number 10, and which is grown in this region in most of the countries in the Saudi Peninsula. Here's another graph with the same curve, world tilapia production from 1970 to 2010. And the market is still expanding, and exports to the US are still expanding year on year. World production, China is slightly less important compared to some others for tilapia. Egypt is a very big producer, and Egyptian tilapia is exported a lot. You will see it in the supermarkets here quite often. Indonesia is a big producer, and Brazil. This was the number 2, Japanese kelp, with a production over 5 million tons. But of course, it has less value per kilo than does fish. In the spring, it's boiled and eaten as a vegetable, but most of it goes for processing to extract iodine, alginates, and a substance called mannitol, which has various pharmaceutical uses. It's been eaten in Japan for more than 1,000 years, and it's an important vegetable for people in inland areas in China because of its high iodine content. It can concentrate iodine to 100,000 times the level in seawater. And as 40% of the Chinese population are deficient in iodine, it's a very important food nutritionally. It's grown in systems like this. Number 5 is the Pacific cupped oyster. There are 2 mollusk species in the top 10, this one and the Japanese carpet shell. This was 5th in the rankings in 2011 with 3.8 million tons. Here's a graph of the growth in cupped oyster production since 1950. Again, almost all due to China, this growth over the last 25 years. This is the Japanese carpet shell. It has a very varied color, but these are all the same species. Number 7 in the rankings in 2011 with 3.7 million tons production. It's grown in shallow tidal areas, in beds like this, managed by small-scale farmers, harvested with small machinery, or sometimes with tractor-driven units. There's potential for this kind of culture in this area, in Yemen in particular, on the south coast, and in Saudi Arabia on the Red Sea. Here's a graph of growth in Japanese carpet shell production. Again, since 1990, almost straight-line growth. Other important mollusks are the Mediterranean mussel and the yeso scallop. It's also called the ezo, giant ezo, Japanese scallop. It can grow up to 20 centimeters in height and 1 kilo in weight. But of course, it's usually marketed at a much smaller size. It has a wide temperature tolerance up to 26 degrees, so it's widespread in East Asia. But this particular species would not do well in the Gulf countries. There are local species, however, that offer possibilities for farming, again, mainly in the Red Sea. So let's take a look at shrimp. This is a black tiger shrimp, Penaeus monodon, number 9 in the rankings with 2.8 million tons in 2011. World production is dominated by a South American species, the white leg shrimp. And this is a recent change since China imported this shrimp from South America and started producing it. It's now responsible for nearly 3/4 of world shrimp production. And by value, similar sort of pattern. China responsible for 40% of world shrimp production. Thailand, Vietnam, Indonesia, also big producers. There is a shrimp farm in the UAE, and there's a very large shrimp industry in Saudi Arabia, but it has been suffering troubles the last couple of years from diseases. That's one of the problems with shrimp, that over the last 10, 20 years, there have been a succession of viral diseases that have affected production. And just this last year in Asia, a thing called the early mortality syndrome, which has badly affected production in Thailand and Malaysia. And it's also turned up now in Mexico. And one of the classic examples of this boom and bust aquaculture is Taiwan, which in the late 1980s was the world's leading producer of shrimp. But highly intensive systems, poor disease management, and perhaps a lack of due attention to environmental issues caused a crash in the Taiwan production, from which they have never recovered. This is one of the aspects of aquaculture that we have to resolve if it is going to achieve its potential in producing food for the world in the future. I'll just flip through a few others. This is nori or lava, big production. You might have come across it in sushi dishes. That dried green stuff around certain sushi. This is Gracilaria. This is a seaweed used mainly for agar production. There's 150 species in the world, all the way from the tropics to the poles. And the commercial species are reddish-brown in color and hair-like fronds that can be up to 1 meter in length. World production in 2010 totaled nearly 2 million tons, valued at $500 million. There's been a big boom in production since 2002. And 9 countries were producing it in 2010, led by China and Indonesia. As this is Gulfood, I'm just going to tell you a bit about this. It goes to make agar. which is widely used as a stabilizer and thickener in the food industry. You find it in pie fillings, cookies, ice creams, cream cheese, pet foods. In the medical and pharmaceutical industries, it's used as a medium for culturing bacteria, dental impressions, a laxative. It can be refined to agarose gel, which is used in electrophoresis, chromatography, and as an enzyme carrier. So it's a pretty valuable and useful product. This is another branch of seaweeds, Eucoima. This also, some species have potential in this region, in the Red Sea or the Arabian Sea at least. These are used for carrageenan production, and there are three main commercial products. One of them is used for kappa-carrageenan and is used for breading and batters in food. Iota-carrageenan comes from a different species, and it's mainly used in fruit products to make soft gels. And lambda-carrageenan, which comes from a South American species, is used for thickening dairy products like yogurts and retaining moisture in dough. There's also a kappa-2 product that you will have drunk in chocolate milk, if you're a chocolate milk enthusiast. Carrageenans are used in ice creams and desserts, sauces, pâtés, toothpaste, shampoo, fire extinguisher foam, air freshener gels, soy milk, diet drinks, pet food, and interestingly have been shown to be effective in reducing human papillomavirus infections, in reducing herpes simplex virus transfer, and as it binds to the receptors, possibly even in reducing HIV transmission. It's another very interesting product. This is wakame. This is a big seaweed, a few meters long, and you may have come across it in miso soup. It's a cold water species, so not much prospect for growing it in this region. But I mention it as it's important in the world seaweed industry, and it's high in omega-3 fatty acids, as well as in calcium, iodine, thiamine, niacin. So it's a popular health food. I'll just run through some of the other major species. Salmon. There are now 2 projects in the UAE to farm salmon here in recirculation systems. This is the growth in Atlantic salmon production, a graph that now looks familiar. Gilt-head sea bream, which is a Mediterranean species, but has been worked with in many of the Gulf countries, and there's production currently here in the UAE. Again, similar graph of gilt-head sea bream production over the last 20 years. Most of it is produced, or half of it is produced in Greece, and Turkey, Spain, Egypt, also big producers. Sturgeon. There's a sturgeon and caviar farm in the UAE, which is the end of last year, began marketing its first product. I wanted to mention up in Al Quwain, the ministry have a research and hatchery center, and they are just building now a very large expansion of this research and hatchery center, the Sheikh Khalifa Center. I understand the hatchery phase should be ready by next year, and then they will move on to 5 other phases. And the objective is to produce fry to supply the local industry with fingerlings of a wide range of fish species. These are some of the grouper in that facility. This is the farm, the shrimp and gilt-head sea bream farm on Barmid Island in Abu Dhabi. And these are some of the other species that people are showing interest in. Grouper in particular, hamor, because there's such demand for it and a good price. Egypt produces quite a lot of mullet. Various kinds of snapper like this, the spangled emperor, and cobia. And I just learned yesterday, talking to one of the Australian participants in this, that they have had success with hatchery production of kingfish, which of course is the other species along with hamor, which is most popular in this region. So there are possibilities for those species probably in the Gulf countries. Well, I'll end there. If you have any questions, I'll be happy to try and answer them. Okay, thank you.